All right, ladies and gentlemen, we are here for our factoring expressions notes. Okay, central question will be, how do I factor an expression? So first, let's back up and talk about what factors are. Factors are numbers that are multiplied together. It's that simple. They are just numbers that we multiply together. For example, so I'm going to zoom in just a little bit. Got it. For example, we have 2 times 8 equals 16. So we have a number sentence here. This would be an example of an equation. Our factors of 16 would be 2 and 8 because we use 2 and 8 to multiply to give us 16. And then we know the answer to a multiplication product we call the product. Correction. The answer to a multiplication problem we call the product. There we go. So factors are just numbers that we multiply together. When you're asked to factor an expression, factoring is simply the process of finding what two numbers, so what to multiply, together to get an expression. So when we ask you for what are the factors of 16, we're looking for what times what gave us 16. So we could do 2 times 8. You know, more factors would be 4 times 4 or 1 times 16. Because all of those, when you multiply them together with their sets, give you the product of 16. So when we're asked to factor an expression, we're looking for what was multiplied together to give us that expression. Now we can sum it up in 2 steps. The first step would be to find a common factor and take it out. Oftentimes when we're doing this year, we're going to look for the GCF. So you can put a little note for yourself. Start with finding the GCF, so the greatest common factor. But when you get farther into math, sometimes you need numbers that are not the greatest common factor. So if you're paying attention, I'll show you how to do both. And then once you find that common factor that you're going to take out, then you're going to divide to find what's left inside the parentheses. So we're going to divide to find what's left inside. So we find a common factor and take it out. Then we divide to find what's left inside. If you need to pause, you can write that down. Go ahead. But I'm just going to keep going. So for my example, we have the expression 6x plus 9. We want to know what does it look like in factored form. So ultimately, we need to get it to look like the following. We're going to have a number, a factor that we took out. It's going to be the one they had in common. And inside is going to be left all the stuff we didn't use. So whatever we had to, what was left over after we divided, So what was left over after we divided. So we're going to break this into steps. So step 1, my lovely step 1, is I look for a common factor. So I'm looking at the numbers here. So this is a coefficient because it's multiplied with x, and I'm going to look at this constant. So what times what gives me 6? So 1 times 6, 2 times 3, and I'm done. And I'm going to find my factors of 9. So 1 times 9, 3 times 3, and I'm done with that. So now I look for what's a common factor, something I can take out because it's both of them have it. So in this case, the GCF is 3. So 3 would be the one I take out. So now on to step 2. So we found a common factor and we're going to take it out. So officially, this 3 is going to go here. That's what I'm taking out. So I take out what they have in common. And now I'm looking for finding what's left inside. That's going to be step 2. So step 2 is to divide to find what's left inside. So I take my original term, this one here, 6x. I'm going to take 6x, divide out 3, and I want to know what's left inside. So 6x divided by 3 is 2x. So 2x gets to stay inside. And because we were adding, it's going to be added 2. And now I take my next term, 9, and I'm going to divide it by 3. So 9 divided by 3 is 3. So that's the other part that stays inside. So now I know what 6x plus 9 could have looked like before. So in this case, I know what it looked like before the distributive property was basically added. Was applied. So before they did all this sharing to get it. So now I have the factors. It would be 3, and the second factor would be 2x plus 3. All of that together. So that is factoring. So we're going to practice. We have 3 problems to practice with. First example, or my next example, is going to be 20y minus 4. Again, I want to know, what does it look like in factored form? So to do this, I'm going to do it like this. So my setup, I know how to set it up. I'm going to get a number that comes out. That's what they had in common. And then I got to figure out what stays inside. So to do this, we're going to do step 1. Step 1, again, you remember, is to find a common factor. So we're looking at 20, which is the coefficient, because it's multiplied with y. So what times what gives me 20? 1 times 20, 2 times 10, 4 times 5, and we're done. Finding what I can do to multiply, to get 4, excuse me. So 1 times 4, 2 times 2. So here are my factors of 20 and 4. As you can see, they have 2 in common. They also have 4 in common. So it's your choice which one you want to pick. If they say use the greatest common factor, then that's what you do, the greatest common factor. In this case, the GCF will be 4. So I'm going to take 4 out. And now I'm going to look for what's left inside. That's step 2. To find what's left inside, I have to divide. So I'm going to take my 20y, I'm dividing it by 4 because that's what I took out. And what was left was 5y, because 4 times 5y gives me 20y. So I put 5y. Now I was subtracting.
Alejandra Carrillo, please report to the front office. Alejandra Carrillo, please report to the front office.
Okay, so I was subtracting in the initial expression, so I need to keep subtraction there. And now I go to my next term. It was 4. So I'm going to do 4 divided by 4 is, and for that it is 1. So 1 stays inside. Now to check your work, you would just do the distributive property. You would say, hey, if I share out this 4 times 5y, does that get me back to where I started? Yes, it does. Does 4 times 1 get me back to where I started? Yes, it does. So you know you've done it right. Now, for you students who are ready for a bonus, some of you noticed that 2 was common. That's right. They do have 2 in common. So you could have taken out 2. If you take out 2, you're going to have something different left inside. But it's not hard to figure out. You're like 20y divided by 2 is 10y minus 4 divided by 2 is 2. So you have options. Here's your first option for an equivalent expression. Here's your second option for equivalent expression where you factored. So you could have multiple ones. All right. Next example. So this will make example 3, actually. Example 3. We have 35, so 35w minus 42. Yeah, 35w minus 42. I'm going to make that plus 42. Let's make it plus 42. All right. From here, we know the setup. We know we're going to take out whatever they have in common and leave inside whatever they don't have in common. All right, from here, we're looking for a common factor. So step 1. So looking at 35. What times what gives me 35? 1 times 35, and we have 5 times 7, and that's it. And then what times what gives me 42? So 1 times 42. Oh, that's even, so 2 works. So 2 times 21. 4 plus 2 is 6, so 3 works. It'd be 3 times, let's see, 14. Yep. And then we could do, does 4 work? No. 5, no. 6, yes. 6 times 7, and we're done. So we're going to look for a common factor. As you look at it, 1 doesn't help you, so don't stop at 1. We see 7. 7 is what they have in common, so 7 is what comes out. And then all we have to do is find what's left inside, and we do that by dividing. So step 2, we're going to divide to find what's left inside. So 35W is the term we're starting with. Taking out the 7, so dividing by 7, we get 5W, because 5W times 7 gives us 35. So we have 5W stays inside plus, because we were adding, and then we do 42 divided by 7, that's 6. So inside would be 6. And wow, this is just going by super fast. We have our final one, so no point in delaying the fun. Example 4, last one of the notes today. We have 40B plus 80C minus 10. All right. So we have our setup, so let's set that up. We know when we factor, we're going to take out what they have in common and leave inside what they don't. And step 1, we're going to find a common factor, most likely our greatest common factor. But if we're ready for the advance, there's more, so you can keep going. Here we go. Let's start with 40. What times what gives us 40? All right, so we have 1 times 40, 2 times 20, 4 times 10, 5 times 8, and that's it. And now we're looking for what times what gives us 80. So it'll be 1 times 80, 2 times 40, 4 times 20, let's see, 5 times 16, and then we have 8 times 10. Woo! And then finally 10, factors of 10, 1 times 10, 2 times 5. Okay, so let's look for what they have in common. We see 2. We can see a 5. And I see a 10. So any of those we can actually take out to find factors for. Let's just start with the greatest one. So 10. If I take out 10, we're going to look for what's left inside. So that would be step 2. So looking for what's left inside. So 40B divided by 10 brings us to 4B. So 4B has to stay inside. It's going to be added 2. And now let's do 80C divided by 10. 80 divided by 10 is 8. And so 80C divided by 10 would be 8C. So that's 8C stays inside. Minus, and then we have 10 divided by 10, which brings us to 1. There we go. So if we take out 10 as our factor, left inside would be 4B plus 8C minus 1. And I just can't. It's too much fun. For those of you who are ready for the advanced version, you're like, there's more in common. You're right, there is. So let's see. See if you can figure out. If you took out instead 5, what would be left inside? And what if you took out 2 instead? What would be left inside? I know you can do this. See you in class tomorrow for your answer.